Welcome back to the exam preparation video series for AZ-700, Designing and Implementing Microsoft Azure Networking Solutions. I am Karl de Winter, a Microsoft Technical Trainer, and this is the third episode out of a total of 5 episodes in this series. Now, in this episode, we will focus on designing and implementing application delivery services. We will cover how to design and implement an Azure Load Balancer, an Azure Traffic Manager, Azure Application Gateway, and Azure Front Door. Here is a list of all the different skills you may be tested on. These are sometimes referred to as may include, meaning they may or may not be on your exam. This list isn't exhaustive, and while we won't be covering every skill in this video, be sure you are able to perform these skills before taking the exam. Let's continue to look at the different skills you may be tested on. Like I previously mentioned, this list does not cover all possible elements. And while we won't be covering every skill in this video, be sure you are able to perform these skills before taking the exam. Azure Load Balancer operates at the OSI layer 4, which is TCP and UDP, and it does that by distributing application requests across Azure virtual machines that can be in multiple availability zones, but they must be in the same region. Azure Load Balancers can be one of two types, public or internal. Public Azure Load Balancers will have an Azure public IP address as the front end and are used to expose applications to the public internet. Now, in contrast, private load balancers will have a front end with an IP address that belongs to the virtual network range where they are deployed. And they are used to expose applications internally within the corporate network. Now, Azure Load Balancers can also be used to load balance any kind of TCP or UDP application. And with the cross-region Azure Load Balancers, IP addresses are used instead of DNS to provide cross-regional resiliency. Azure Traffic Manager can perform multi-regional load balancing over the public internet when an application has a footprint in multiple Azure regions. Now, Azure Traffic Manager uses DNS technology to send user requests to its backend endpoints, resolving application client DNS requests to one of multiple IP addresses based on a set of configurable routing algorithms. Now, one important implementation of Azure Traffic Manager is that it only provides DNS resolution for public IP addresses, which means that it can only be used to load balance traffic for applications that are accessed over the public internet, but not for applications accessed over a private network. So make sure before the exam you revisit the important points on this screen. Azure Application Gateway is a layer 7 load balancer, and it operates at the HTTP/HTTPS layer. It is a full HTTP/HTTPS reverse proxy, which means that it will terminate the client HTTP connections and initiate new ones towards its backends. Azure Application Gateway can offer very interesting functionalities: load balancing on URL or host header, cookie-based affinity, SSL decryption, and encryption. Now, the V2 SKU of Application Gateway includes the following: auto-scaling to scale out or in based on changing traffic load patterns. It can scan multiple availability zones. It has static VIP type, and it allows you to add, remove, or even update HTTP request and response headers. Application Gateway V2 Ingress Controller allows the Azure Application Gateway to be used as the ingress for an Azure Kubernetes service. Application Gateway can be configured to scale in 2 modes. In manual mode, the gateway doesn't auto-scale. With manual mode, specifying instance count is mandatory. Instance count can vary from 1 to 125 instances, and use auto-scaling to scale out or in based on application traffic requirements. Now, some things to remember for the exam. Now, a backend pool has 4 types of backend members: a virtual machine scale set, an IP address or FQDN, or an app service. And a listener checks for incoming connection requests by using the port, protocol, host, and IP address. If the listener supports HTTP as well, then you can enable end-to-end TLS. Now, traffic will be routed to the backend servers by using the HTTP setting. So you must associate this HTTP setting with one or more routing rules. And App Gateway monitors the health of all resources in its backend by default. Frontor is not deployed in your virtual network like Azure Application Gateway. Instead, it is configured in specific point of presence locations, and those locations are at the edge of Microsoft's network. Azure Frontor is ideal for deployments where application clients are spread across different geographical regions because its caching capabilities will improve the performance of users sitting far away from the actual application service. So it's using URL path-based routing for requests. Azure Frontor is used for internet-facing applications to deliver secure, scalable, and high-performance application delivery globally. So make sure you understand for the exam that Frontor and App Gateway are two Azure services with similar functionality. While one is a global service deployed in Microsoft Edge locations, the other is a regional service that exists in Azure regions. Know that Azure Frontor has two different tiers, Standard and Premium. The Premium provides features as Web Application Firewall managed rule sets, bot protection, and private link support. You can create an Azure Frontor through the Quick Create or Custom Create option. The Quick Create option allows you to configure the basic settings of your profile, while the Custom Create option enables you to customize your profile with more advanced settings. Now, Azure Frontor supports origins hosted in Azure and applications hosted in your on-premises data center or even within other cloud providers. After you add an origin, you also must add a security policy. A Frontor routing rule matches incoming requests based on protocol, domain, and path. That's what we call the left-hand side. And then it processes them by either serving cached content or forwarding the origin if no cached response is available. And that's what we call the right-hand side. Know that while creating a route, you can choose to redirect specific protocols. For example, you can redirect HTTP to HTTPS. Azure Frontor supports caching of static content. You enable caching on the route that you created in the Frontor profile. And you need to specify the query string caching behavior, and optionally, you can also select Enable Compression to compress responses to the client. Anycast allows for user requests to reach the closest edge location on the fewest network hops with the help of what we call fallback rings. You can implement rules to set URL rewrite settings and redirect traffic at each of the following levels: protocol, hostname, path, and query string. You can configure Frontor's origin to connect to private link and access Azure PaaS services and services hosted in Azure over a private endpoint. To recap, in this episode, we discussed how to design and implement Azure Load Balancer, Azure Traffic Manager, Application Gateway, and Azure Frontor. Remember, this group accounts for 15 to 20% of the exam, so keep that in mind when preparing for the exam. Now, thank you for watching the AZ-700 Designing and Implementing Microsoft Azure Networking Solutions Exam Prep video series. We hope that this series helped you understand the skills that you're strong in and areas where you might need to revisit. Remember that understanding these concepts is crucial for your success. Be sure to leverage other exam prep resources such as the study guide, practice assessments, and exam sandboxes.